Now, this based on what I discussed, since you have understand the proving, alhamdulillah, the next thing, let's be seeing question backing all this topic. Now, the first question is jamb question number 23, 2007. Let's see. A charge, you know what we mean by charge. Let's be putting out, let's write data given. Data given. The first thing to come to your mind as a science student, data given. A charge, what is that? The symbol for charge is what? Q. A charge, this. So we are given Q to be 50 U what? UC. We call this U, we call it microcoulombs. You know the standard unit is coulomb for charge, but they want to make it to more bulky. They put it what? Micro coulombs. Are we together? So wherever you see U, you call it microcoulombs. And for you to convert UC to ordinary C, it is, you multiply this 50 times 10 raised to power minus 6. 10 raised to power minus 6 is what we call micro. This C is microcoulombs. So for we to change UC to ordinary C, 50 will be multiplied by this. So we will be left with C. Hope I'm communicating. Are you to me? Are you together with me? If it is pico is 10 raised to power minus 12. Nano, 10 raised to power minus what? Minus 9. Milli, 10 raised to power minus 3. So these are the sub-unit they can use. So you have to convert them to the standard unit for electric charge, which is C. So let's quickly do that. So this will now be what? Now 50 times 10 raised to power what? Minus C. This is the first thing to do. Now let's continue. As an electric field intensity. No, has an electric field strength. Note that, don't let this confuse you. I told you when I'm defining electric field intensity, I said it is the strength of an electric field. Are we together? So another name that they can call electric field intensity is also still the same thing as electric field strength. Electric field strength is still the same thing as electric what? Field intensity. These are the two names they can call it. So even it is three names. Is either they call it electric field intensity, or they call it electric intensity, or they call it electric field strength. So it's still the same thing. So note that means electric field strength that they call it here is still the same thing as electric field what? Intensity, which is what is the symbol? Capital E. That is the symbol for electric field what? Intensity of 36 360 Newton per coulomb. Even if you don't want to be able to understand what I mean by this, just check the SI unit is at the back of this one. Even if they didn't mention this name, check the SI unit. It is Newton per coulombs. And Newton per coulomb is for what? Is for the SI unit is for electric field what? Intensity, F over Q. Now this will now be 36 Newton per coulomb. So another ways of dictating what you are given. Check the SI unit. Are we? Which will be E equals to F over Q equals to Newton, while C equals to what? Coulombs. Newton per coulombs. That is how they get this. And know that anything Newton per coulomb is for E. So even if they didn't mention this name, Newton per coulomb that you are seeing, it will quickly tell you or notify you that it is E that you are given. Are we? 360. Sorry for that. 360 Newton per coulombs. Newton per coulomb. That is E. Let's continue. Now, at a certain point, that means at a certain point, he has Q and he has E. Let's continue. The electric field strength due to another one. That means electric field strength due to another one. They still mention electric field strength, which is still the same thing as E. Due to another one. Are we given anything? This is not electric field strength. They just want to make it to, for you have to comprehend the question. It is not this. This C that you are saying, you see, know that it is Q. Another Q. So the electric field strength due to another Q. That's what they mean here. Due to the electric field strength due to this Q we are given, which is this. Now the electric field strength due to this one we are not given. That means what I'm saying, that we have Q here, we have E here. This one too, we also have E here, we have Q here. Now that means, try and understand this question. That means we are given Q, we are given E. Here now we are given ordinary Q. You can call it Q2. Since this one is 1, make this one Q1. So automatically we are given E. Make this one E1. Then here we are not given E. We can make this E2, which is unknown. Then we are given this one. Due to another charge, I told you this will be charge. Check the unit, UC. Check this one to UC, which will now be Q what? Q what? Q2, which is what will that be? 120 microcoulombs. Hope I'm communicating. I told you the same thing, you convert this one to C. We don't need this. It will now be 120 times what? 10 raised to our minus C. How we? Everything is balanced. These are all the parameters that we have. Let's continue. Kept at the same. Kept at same. Kept at same means they kept them constant. Are we? Like when you are defining Boyle's law. Boyle's law states that the pressure of a given mass of what? Gas is what? Is inversely proportional to the volume, provided that the temperature remain constant. So they said kept at constant. That means they kept some, apart from these parameters, they kept some parameters constant at maybe 0. They kept it as 0. What are the parameters? Kept at constant. So if they don't want to use kept at constant, they can still use kept at the same. It's still the same thing. What did they kept at the same? Distance. What is distance? The symbol for distance, for this, as far as this topic is concerned, it is R. That means R here, it is 0. When they say kept at constant. What again? Apart. And in the same medium. In the same medium mean, you know, for all these things to happen, it must undergo what we know as, since you are seeing Q1 here, Q2, it must undergo what we know as Coulomb law of electricity, where we are going to be dealing with F, Q1, Q2, all upon or what, 4 pi E naught, all that kind of thing. Are we together? So all we need to, that means K now is also what? Constant. Oh, that is, and in the same medium. That means at Coulomb's constant, which is K. I told you that Coulomb's constant, it's F, K, Q1, Q2, all upon R squared. So they kept this as constant. They kept this K2 as what? At constant. Are we together? So these are the two things they kept at constant, which this one will also be was 0. That means, what do they mean by that? We don't need R, you don't need K. This is your concern. But they want us to know, why are they bringing R and K? That means you find a formula that have R and K, but you won't use them. You won't use R and K. We only use Q1, E1, E2, Q2. But this one is telling you, they are telling you that the formula that you are to use if you want to get E2, because here now, based on this, we are not asked to calculate anything here. But note, are we given E2? We are not given. That means that is what they want you to calculate. So that means in the formula you will use, all these are the parameters. Q1, E2, E1, no, Q1, E1, E2, Q2, R, K. But they kept R, C, they kept R, distance apart. They kept it at constant, at the same, 0. They also kept what? In the same medium. They also kept K as constant. But you have to bring a formula that involves all these things. What is the formula? The formula is E equals to, based on what I explained, E equals to what? K. Hope I'm communicating. You know, from the Coulomb's law of electricity, we are able to discuss that we have E equals to F over Q. And I've proved that. So let me erase this one. Let me erase from here now. Let me erase from here. Here now. And I've proved that we have F equals to what? We have F equals to, what is our F? F is K, Q1, Q2, all upon what? All upon R squared, isn't it? All upon divide by what? Divide by Q. Hope I'm communicating. So now already they have kept this one. This is the formula. Although, do we need R here? R is 0. Do we need K? K is 0. Hope I'm communicating. So they have kept this constant. Hope I'm communicating. So that means all this one, you don't need to use it. Since all our formulas involve E, K, Q, Q. And what we have is E, K, Q, Q. Hope I'm communicating. Or let's do it like this. Q cancel Q here. We are left with what? E equals to K. Let's do it like that. E equals to what? KQ. Isn't it? When I settle this with this, So you know how I settle that. KQ, you can put 1 here. So all upon what are we having? R square. Hope you get what I'm saying. So if this is Q1, you can make this one to be E1. This one will be K1. This one can be R1. So that means, and based on this question, we also need E2, right? You can still bring this same thing. E will now be E2, K what? K2, Q what? Q2, all upon what? R square 2. Are we together? What are constants here? We don't need this one. It is constant. R is 0. It is constant. Even if I put a 0 square here, I will still get 0. K is also constant. We don't need it. We only need E1 and Q1. Here we only need what? E2 and what? Q2. Open. This is also constant. This is also, that means we don't need them. So now, based on this, I've proved the formula. Based on this, so we are left with only what? We are left with only what? We'll be having E1 equals to what? Q what? Q1. Make this equation 1. E2, and I've proved how I get this. E2 equals to what? Q2. Make this what? Equation 2. These are what we need. So this, we don't need them. R and K, we don't need them. Now, relate this together. How do we relate this together? Is that, since, you know, we have K here before, isn't it? Which is K1, right? Aha. And we don't need R. Let me even do it like this. For more understanding, this, we have what? We have K2 here and Q2. We don't need R. I've erased R. Here too, we don't need R. I've erased R. Leave K. We are still going to erase K, but leave K for now. Because I want to make K the subject of the formula here. Electric Coulomb's constant. I want to make it the subject of the formula. Let's do this for the first one. What is the first one? The first one, these are the answer. Don't let me clean the answer. The first one is that E1 all upon KQ1, K1, Q1, make K the subject of the formula now. This will be divided by Q. Although we later erase this K, because they kept both K and R constant. Are we? So, but right now I've erased R. I'm still going to erase K, but I need it now for me to get the formula that I need to use, the appropriate formula for me to use here. Oh, and I know you know how I arrived to this formula from this something. I've proved that. Now this will now be Q1 is here, all upon Q1. Divide both sides, divide through to make K, in order to make K1 the subject of the formula. Q settle Q here. We are left with what? E1 all upon Q1. This will now be, therefore this will be K equals to K1 will be E, or you can make it ordinary K anyhow. E1 all upon what? All upon Q1. Hope I'm communicating. You still do the same thing to this second one. What is that? It will be E2 equals to K. You can put 2 or you can leave it. K is K. K1, K2 is still the same thing. So, since it is constant, it is the same thing. Equals to what? Equals to Q2. Divide both sides by Q2. Divide this by Q2. This settles this. What are we left? K equals to E2 all upon Q2. This formula, this question is very simple. But for you to understand well, that is why I'm taking time to break it. All you need to is just cram this formula. If you can't cram, if you are unable to know how I get this, cram this formula and cram this formula. This is what I want to use. Then relate K equals K. Since K, we have K1 here, K2 here, relate them together. Hope I'm communicating. Let me erase this. What do we have for K1? You will just say K equals to K. K this one equals to this K this. What do we have for the value here? Since we are dealing with E, we are not dealing with K. They are 0. I've erased them now. I'll substitute in the value for K. You can make this K1, K2. Let's substitute in the value. We have E1 all upon what? Q what? Q1. This K2, which is this one, we have what? E2 all upon what? Q2. This is the best formula we need. So then what are we looking for? E2. Based on this, make E2 the subject of the formula and you get your what? You get your result. Hope I'm communicating. But I just want you to know how I will actually get this. You know, for me to just bring this and start using, you won't be able to know how they get it. If you want to know how they get it, you follow how the step that I follow, then you get it. Or you cram this one and you use it to solve this question. Are we together? E2 now times Q1. Because E2, that is what we need. Cross multiply here. E2 times Q1. For we to make E2, the subject of the formula, you have to do a mathematical expression here. E2 times Q1, E2 times Q1 equals to what? E1 times what? Q2. E1 times what? Q2. Are we? Divide both sides by Q1. Divide this by what? Q1. This one, settle what? Settle this one. What are we left with? E2 will now be what now? E1 times what? Q2 all upon Q1. Then substitute in your parameters. What are the things that we need to substitute here? Let me erase this. Sorry, my board is too small. Let me erase this and bring this up. We have E2 equals to E1 times what? Q what? Q2. All upon what? Q1. Let's try and put into this. This is the formula I'm going to. What is that? What is our E1? Our E1 is this. You now come E2. For we to get E2, E1 is 360 times, what is our Q2? Our Q2 is 120 times 120 times 10 raised to our minus 6. I told you that you can't use 120, you have to convert. All upon, what is our Q1? Our Q1 is 50 times 10 raised to our minus 6. Are we together? So the next thing is that let's try and find a calculator, and you should compress this and we get the results. And that is just that on there. So what do we have here? Sorry. 3 now. So I've pressed the calculator. 360 times 120.